is also MZ is also what? Compression. That's why I'm telling you not to worry about the plus or minus on the standard formula. Okay, you look at this analysis, you are able to identify what is your uh, whether is it positive or what negative. So the next easy thing to do is the my and IYY. So our my, okay, so our my will be equal to minus, okay, my is 3420 divide by IYY. So we have found our IYY to be what? To be our IYY to be 64. Is our IYY go to 64? Let me check. IYY 64. Yep. Okay. I'm going to not write Z first. Okay. So minus by MZ. So MZ we have written earlier to be 9396.9. 9396.9 divided by IZZ of 88. Now the next point where everyone, including myself, have issue is this Z and Y. Okay, so we know that Z and Y, right? Z and Y, okay, Z or Y and Z distance are, okay, distances are from the centroid. The problem that most of us have is the direction. Okay, so can anyone tell me at point A, okay, what is the Z distance? Anyone, please? Is it going to be 1 or is it going to be 4?
4 inches.
4, right? Right? Why? Because if you look at this Z distance, this is the Z distance, yes or no? Right? So the Z distance, so we know that this is the neutral axis. The Z distance is over here, so it's going to be what? 4. Okay, so you multiply by 4. And then the Y, so this is the relative from the neutral axis or the centroid. The Y is equal to what? 1. So that's why it's so important to identify which is your Y and which is your Z. Okay, so this will be equal to 3420.2 times 4 divided by 64. So this will be equal to minus 213.763, and then minus by 9396.9 divided by 88 is equal to 106.783. So this will be equal to 13.763 plus 106.789. So this will be equal to minus 320, right? 320.546 psi. Okay. And then the next one, we're going to look at stress X at point B, right? So again, you have your My over Iyy, right? Multiplied by Z. And then you have your Mz over Izz multiplied by Y. So at point B, which is this point over here, I'm going to use a different. So at point B, right, which is this distance, which is this point over here, right? So if we look at My first, right? So My at point B is still going to be compression. So you have minus, right? And Mz at point B, right? So this is the neutral axis, or this is your axis, right? So below the axis, Mz is going to be a tensile. So this is going to be a what? This is going to be a plus. Okay, so that's how you identify your plus or your minus. So this will be equal to minus 213.763 and then plus by 106.783. Why I copy these values over here and change the vectors because they share point A and point B share the same magnitude of y and z value. Only the direction changes for the mz. Okay, so this will be equal to minus 213.763 plus 106.783. So it's equal to minus 106.98 ESI. And then finally, stress stress x. Okay, so our stresses are all in the x direction. At point D will be equal to, again, just put in the formula first, over IYY Z plus by, we don't know yet, okay, MZ over IZZ multiplied by Y. Okay, so if we look at moment at Y, right, if we look at moment at Y at point D, now we're going to focus at point D now. So this is where our interest at point D. So moment at Y, point D has a centroid, so therefore this will be equal to what? 0, right? This will be equal to 0. And why this will be equal to 0? Because Z is equal to what? 0. Okay, because at point D, about moment about Y, point D is exactly at the what? Central axis. Okay, now you look at MZ. MZ is going to give you tensile at point D, so plus by MY, so our MY is equal to 939. Okay, so it's going to be 9396.9, and then divide by IZZ, which is 88. And the distance Y now, so you know that Y is in this direction. So from here to point D, your Y is equal to what? 4. Okay, so this is equal to 4. So this is going to be 9396.9 times 4 divided by 88. So it's equal to 427 tensile positive 427.132 ESI. Okay, so this is the first example. What you see now is your first example on what we have in a condition of loading that is known as unsymmetry loading. Any questions so far?
Yes. Is MZ supposed to be 9,396?
Yeah.
Oh, my bad. Sorry.
It's okay. Yeah, I better check. Yes, it is. Okay. I'm right? Tell me if I'm wrong.
Yeah.
Okay. Okay, thank you. You get a pint. Okay. Anyone else? No? Okay. So next thing, I'm going to show you a derivation on how to locate the location of the neutral axis. Okay, so the next one is how to locate the position of the neutral axis. Okay, so I'm going to draw a diagram. Okay, I'll start simple shape first. Again, rectangular. Okay, and then we have our axis. Okay. So this is our axis. This is X. Sorry, this is Y. And this is Z. Okay. So if I copy and I paste, and I'm going to do a rotation by 45 degrees. It's not rotating, is it? I'll do it again. So it's going to rotate by 45 degrees yesterday. Right. Don't be like me when I'm young. See nothing. Can you observe what is going on? Anyone? Okay. What do you observe? CD Kura, AS as you say yes. So what do you observe? Or anyone?
So the neutral axis is gonna be on a plane.
Okay,
Like
not the neutral axis. The transformation, okay, will rotate following the what? The object. Yes or no? Right?
Yeah.
So when I rotate, the axis follows the object. The axis is not following planet Earth. It's not a fixed frame. Okay, it's moving relative to the object. Okay, right. So the transformation. First thing to take note: the transformation or the axis rotates with the object. Okay, so that's the first thing you have to think. Okay, the axis rotate with the object. Right. So we know it can be either one. Okay, so let's focus on this diagram over here. Okay, let's focus on diagram. So we know that stress X. Okay, so we know that stress in the X direction will be equal to my over Iyy z minus by mz over Izz y. Okay. So this is what we have. So I'm going to call this our equation number 1. So we know that at the neutral axis, okay, at the neutral axis, stress X will be equal to what? 0. That's why we call it the neutral axis. All right. So I'm going to put I'm going to take note down here that note the position of the centroid is not always the neutral axis. And later on, I'll show you why. Okay. Okay. So at the neutral axis, stress X is equal to 0. And then we're going to substitute into equation number 1. So we have an expression where 0 is equal to my over Iyy z minus by mz over Izz y. Okay. So then you equate both of them. So when we rewrite this, you have mz, right? We can have mz over Izz y is equal to my over Iyy z. Okay. So this I will call my equation 2. So if we have a transformation now, okay, so if we have our vector now, so I'm going to draw our transformation again. So we know that this is our axis. Right. So this is our y. and this is our Z. And this axis, both of these axes, right? Both of these axes will follow the